comprised among the optimal ones, because you see, in this case, if I wanted to take the average benefit, the optimal decision is the fourth, which is not an optimal one according to the three possible realization of the parameter vector. This means that, of course, there could be a decision, which I did not consider, that could be even better. So this is a thing that you have to consider, of course. When you identify your possible decision, not necessarily you should limit yourself to the optimal ones. But again, even if you decide according to these two criteria, you are not using the utility theory. To use the utility theory, as I said, you have to define the utility for each possible benefit. Now, before defining the utility, let's make a premise, and the premise is the definition of the dominated decision, because dominated decisions are not interesting for us. And it's therefore very much important that we identify if there are decisions that can be rejected from the beginning, because this simplifies the problem. What is the definition of dominated decision? A dominated decision, you see the definition here, is such that the benefit, let's identify the decision with the letter capital B. In this case, there is a bit of inconsistency in the notation. I should have used capital X here. So here B indicates the decision, and therefore a decision is dominated. The decision B prime is dominated if the benefit that we take with the decision B prime is always inferior to the benefit that we take with another decision P. So if we have a decision P prime whose benefit is always inferior accordingly to each value of the parameters, is always inferior with respect to the benefit provided by another decision, we can reject P1 from the beginning. And this is very important. In decision theory, it's important that you know the meaning of the definition of a dominated decision. It's a decision that is not interesting, because there is at least one other decision which always gives a greater benefit. Even in the presence of uncertainty, whatever the parameters of the benefit function are, the decision can be discarded. And so if you have here, I go back, you don't have here a dominated decision. But if you have here a dominated decision, which means a decision whose benefit is always inferior to the benefit of the other one, you could discard it. You see that in this case, even 4 is not for the optimal decision are never dominated, of course, because they are at least the best one according to one parameter vector. But even the fourth one that I identified by chance, you see that in this case, you cannot find a decision that is always gives a greater benefit. You see that in this case, okay, you find this decision that gives a greater benefit, but in this case you find this one, so it's not the same, and in this case you find different decision, but it's never the same. So you should find at least one decision that for any parameter vector is provides always a higher benefit. Now, let's assign to each benefit above a utility. And I already said that you have to start from 0, minimum benefit, and you have to get to 1 for the maximum benefit. And then let's assume that our utility is defined in this way. This is just, don't ask me how I defined it. It's just an exercise, an hypothesis, okay? You could select a different utility function, and then you would get, of course, different results. You may try to change. And this is a kind of utility function that is a bit, I would say that with respect to, is a bit risky because you see that it's not jumping directly to 1 from the beginning. Here I should have limited the y-axis to 1 because it's meaningless to extend it to 1 to. Okay, let's assume that we have this utility function then. And then the question is how to identify the allocation that gives to me which is preferable. How to identify the allocation that is preferable. You can't just say I take the benefit that has the maximum utility because this is the maximum benefit. So the answer is not just to take the decision that gives to you the maximum benefit. Because I tell you in a moment, because you can't do so. So what is the question? The question is, how do I select the allocation that is preferable? Because one may say, okay, I take the allocation that gives to me the maximum benefit, because it has the maximum utility. This is not correct. Let me explain why. If you take the allocation that gives to you the maximum benefit, it's 28. But you don't get it for sure. You get the maximum benefit with probability 1/3 if the parameter vector is W1. But if the parameter vector is W2, you get a lower benefit. And if the parameter vector is W3, you get the minimum benefit. Therefore, you can't just say, I take the maximum utility, therefore the maximum benefit, therefore an allocation of 28, because you are not sure if you allocate 28 to get the maximum benefit. So one thing is to identify the maximum benefit. A different thing is to identify what is the preferable allocation. Therefore, what I should say is that if you select an allocation of 28, you get the maximum benefit with probability 1/3, but then you get a benefit of 74.97 with probability 1/3, and you may get a benefit which is the minimum with probability 1/3. So the resulting utility is not 1, is a mix of the utility of the maximum benefit, which is 1, a mix of the utility of the benefit of 74 times, that 97, which I don't remember what is, let's see later, and in the mix there is also the utility 0, with probability 1/3. So we have to compute an average utility for the allocation of 28 and any other allocation. So this is my utility function then. And you see that the allocation of 28 could give, if you remember, a benefit of 74.97, which has a utility of 0.6. So the allocation of 28 could get utility 1 with probability 1/3, utility 0.6 with probability 1/3, utility 0 with probability 1/3. So let's compute then the resulting overall utility. You see? What I just said is written there, and therefore we will have 1/3 probability to get 1, 1/3 to get 0.6, and finally 1/3 to get 0. Therefore, the expected value of the utility is 1/3 times 1 plus 1/3 times 0.6 plus 1/3 times 0, which gives 0.53. So this is finally the utility of the allocation 28 is 0.53. Which means that the user does not find any difference between the decision 28 and the decision that gives the maximum benefit with probability 0.53. Of course, the utility can be computed for all the 4 decisions that we have considered, and therefore we obtain. Where is the table? Sorry, no. I thought I had a table showing the utility of. It's not here. Okay, let me say that you can do the same computation for any decision by considering the utility of all the benefits. I thought that you talked with me the resulting, the final result, but it's not here. Let me check. I think I can find it. So we can identify the decision that gives the maximum utility. Let me see, because this is just a mistake. The Italian version of the slides, and so I think in the Italian version, I think it's there. This is, you see, the same, it was the same exercise, so the same utility function, and then here it is. So you see 0.53 for decision 28, 0.5, 0.52, and 0.57. Again, we see that accordingly to the utility function that we define, the best decision is the 4th one. It's not comprised among the optimal one. So of course this could induce some doubts about the opportunity to evaluate other decisions. And you may check what happens if the utility function changes, if you give a different shape to the utility function. Okay, now I'm ready to start with the exercise, and I will propose to make the break now of 15 minutes and then go straight for a couple of hours with the exercise. Meanwhile, the exercise can be downloaded. It was already available, I think, 2 weeks ago on my website. It's a stochastic simulation and a bit more complex of what we tried to do so far. And there is also a proposed R code for the solution. So what I would like to do is to go through the R code that I proposed, because, as I said, the exercise is much more detailed with respect to what we did, and there are some instructions in R that you don't know yet. So we have to go together through the code that I proposed. But it's already there, should be working, and also the data set is already available on my website. So I propose to start in 15 minutes from now. Is somebody of you remaining here? Qualcuno rimane?